Starting with the engine, it's a Perkins Tier 4 engine. It's a Tier 4 final, suitable for use in the US. It's a compact 4-cylinder engine producing 170 horsepower. We are directly driving the Hughes HP 170 pump, which has a built-in gearbox, which is a very efficient way of reducing the pump speed. One of the very unique features of the pump is the SAE housing here, which gives us several benefits. The main one being is that we get perfect alignment between the engine and the gearbox on the pump, so we don't have to worry about misalignment between the input shaft and the pump shaft. This will drastically increase the life of the drive coupling and the bearings in the gearbox, making them effectively maintenance free. The other significant benefit that the direct coupling gives us is that all of the torsion, all of the torque, is now transmitted directly between the engine and the pump. They almost become a single component, whereas on a conventional pump that is foot mounted, the whole chassis is subject to that torsion, which means the chassis has to be rigid enough and heavy duty enough to withstand that twisting motion. With this direct coupled design, there is no torsion through the skid, which gives us the opportunity to have a very, very compact, lightweight subframe and skid base. So that's one of the main reasons why our pump is significantly smaller than the other pumps you might see in the market. So moving on to the power end of the pump, as I say, there's an integral built-in gearbox which gives us approximately a 4-to-1 reduction in speed. So the engine runs at about 2000 RPM, the pump crankshaft is down to 500 RPM. So that is a low speed. That reduces the strokes per minute on the pump, which increases the life of the valve gear in the pump head. But as importantly as the RPM of the crankshaft is the stroke length of the plungers. On this particular pump, it's around about 3 inches or 75 millimeters. So the combination of low crankshaft speed and a short stroke gives us a very, very low velocity of the plunger. Typically, our plunger speed is 4.1 feet per second, which is the lowest you'll see in any high pressure pump on the market. Typically, other high pressure pumps will be running at 5.5 feet per second up to 6.5 feet per second. The real advantage that gives us is that reduced speed significantly increases the packing life, and at 40,000 psi we routinely see 500 to 1,000 hours life from the packings. The other contributor to the extended seal life is that we decouple our plunger from the pony rod, so there's actually a flexible attachment between the two. This means that the plunger is not fighting against any movement on the pony rod. This allows the plunger to centralise in the packing and not bias to one side. So the combination of the two gives us a very, very good seal life. In addition to that, our plungers are solid carbide, tungsten carbide. They're not ceramic, and they are not a steel plunger with a ceramic with a tungsten carbide coating. They're a solid carbide material. That is a very dense material, which means we can get a very, very fine polish onto the surface of the plunger, which reduces the friction on the packings. So the combination of speed, stroke length and the plunger design gives us incredible seal life. We have a built-in oil pump which gives us a pressurised oil supply to all of the moving parts inside the pump, so the main bearings, the shell bearings, the small end bushes and the crosshead bores. So we're feeding 80 psi of oil straight into the crankcase via an oil filter, so we're taking any particulates out of the oil. It then passes through this oil cooler, so we use the incoming water to the pump to actually cool the crankcase oil. We have some shutdown protection on the system, so if the oil pressure drops to 30 psi, we will automatically stop the engine. If the oil temperature gets to about 80 degrees Fahrenheit, we will actually stop the engine again. So the pump is completely monitored and almost maintenance free. All we have to do is every 500 hours change the oil and change the oil filter. Moving back to the fluid end, we've designed the pump in such a way that maintenance is very simple for the customer. So there are 3 completely individual cylinders connected with a common manifold across the top. So the manifold allows water in and ultra high pressure water out. So when you're in the field and you need to carry out some maintenance on the pump, some unexpected maintenance as opposed to routine maintenance. So for example, if you feel a hot spot on this component here, that could mean that the packing is letting by. We can actually get to that packing very, very quickly by removing these 2 bolts in the manifold, 4 nuts on this cylinder head, which enables us to bring the whole cylinder out and gives us access to every component in that cylinder. At the same time, we're not disturbing the 2 adjacent cylinders, so it's very, very fast, very, very simple maintenance. So that's just a quick introduction to the pump. I hope you found that interesting. Thank you.